Okay, everybody, this is a guided walkthrough for the Verdejo challenge from Dockerlabs. And we're going to be showcasing a very specific web app vulnerability in this walkthrough. Let's go ahead and get started. So over here, let's move into the downloads directory. So we've got the Verdejo file. We've already downloaded it in this case. But if you wanted to download it yourself, then you would go over to this link over here. So for these Dockerlabs challenges, you basically deploy a vulnerable Docker container, and then you hack against it until you get super user access. But after you've downloaded the file, you're going to get this. You're going to see this zip file over here. It's called verdejo.zip. All you need to do is unzip the file, and then after you've done that, you're going to wind up with a tar file, and you're going to wind up with a autodeploy.sh file. So it's the autodeploy.sh file that deploys the Docker container. And the way you would use it is, first of all, you need to make the script executable, and then you need to run the script on with the verdejo.tar container file. Okay? So after that, Dockerlabs will deploy the container. Of course, everything in Dockerlabs is in Spanish, but that doesn't really get in our way too much because we have technology on our side that we can use to translate the Spanish. So the IP address that we're going to be accessing it on is this one right here. So 172.17.02. This is going to be the same for almost everybody. The Docker containers usually use the same IP addresses. Okay, so the first thing we do when we do any of these network challenges is we have to run an nmap scan. So we'll run the nmap scan with these arguments over here. We scan all of the ports with this argument here. We do ports. We do versioning on all of the services that we find with the S_V and run common scripts on them with S_C. We run it very fast but not too fast with the -T4, and we get very verbose output with -VV. Okay, so we scan the server and we find 3 ports. There's port 80 open, there's port 22 open, and there's port 89 open. So what we need to do first is we need to figure out what's running on these ports. So port 80 is pretty common, and it usually runs HTTP, which is unencrypted web pages. We also have port 22, which runs SSH, which is secure shell login. And port 8089, I'm not too sure if this is a common port that is used. We could probably look this up really quickly over here. Let's see. TCP port 8089, because a lot of these services are using well-known ports. Okay, so TCP port 8089 is primarily associated with Splunk, specifically its management interface and API. So we're going to find that that's not the case for this application here. What we're going to do is we're just going to access that port directly by accessing the IP address on port 8089 for this server. And we get this result over here. So we don't really know what this says, but we can always translate it. So nada interesante que buscar. Buscar means find, I think. Interesante means interesting, and nada means no. So nothing interesting, find. Okay, let's translate it. From Spanish. Nothing interesting to look for. Okay. So this webpage here, this webpage is vulnerable to a very specific attack. So it says no hay nada en serio no toques. let's hold on. No hey, nada, en serio, no toques. Okay. No hey, intisario? Intisario took us. No toques. Ah, okay. There is nothing of interest, do not touch. Great, that's what it says. All right, so if it says hola here, right? This means hello in Spanish. If we click on confirm here, okay, so no hay nada aquí de verdad. So verdad means really or truly. So aquí means here, not here. Nada aquí, there's nothing here for real. I think that's what it says. So the important thing is that the thing that we put in the message field here, test, it was echoed out by the application. So in this case, there's some interesting things going on. So this is the Verdejo box. We're dealing with an SSTi vulnerability in this case. So SSTi is a web app vulnerability where the app uses a templating engine to create web page content. So the application uses a template. So the template, there's a bunch of different templating engines, but they allow you to create dynamic output in your web pages. In this case, because the user is able to provide something to the templating engine, it could be used as a form of attack. So if the app is coded insecurely, a user could inject malicious code into the app to interact with the templating engine to achieve remote code execution on the app. So the most common thing we do when we're testing for SSTi vulnerability is we try to make the application do some mathematics for us. So for example, we can give this payload right here to see if we can get the mathematics to work. And let's go back. So this is the app here. So instead of test, we're going to put our mathematical payload in here. It's 7 times 7 inside of these brackets. So if we give this payload and it actually does the math for us, that's a sign that this is vulnerable. So hola 49. So it did the math for us, which means that we could potentially inject into this application with the server-side template injection. So where were we? Here. So a very common way to identify a potential SSTi vulnerability is when we find a web page which echoes back user input. So if we echo out HackerFrogs rule and the application gives us the output HackerFrogs rule, in this case, it's just, whatever we put into the app is echoed out. This is a sign that it's vulnerable. So if we can ID such a web page, we can confirm the vulnerability by having the app perform math operations. So this is the payload we use to check to see if this is vulnerable to server-side template injection. So the other thing that we need to understand when we do server-side template injection is we need to identify the templating engine that is used to create the web page content. So in this case, if we were to make a use a curl request and get some verbose output, it tells us that the server name that is being used for the application is Workzug. So Workzug is it's associated with a very specific templating engine. So Workzug is used with the Flask web framework. So this is a framework that is written into Python, or written with Python rather. And it's commonly used with the Jinja 2 templating engine. So let me illustrate something. So let's see, server-side template injection, flowchart. There are a bunch of different server-side templating, well, there's a bunch of different templating engines that web apps could use. And this is a pretty good article right here. Okay, so identifying SSTi vulnerability, it's basically if you can get the web application to output user input, that's a pretty good sign. So from here, what you need to do is you need to identify which templating engine is being used. So you could use a bunch of different templates here, or a bunch of different payloads. So we start here, we would give something like this, and then we would follow the flowchart to figure out which templating engine is being used. So if you do this payload here, and it gives you mathematical stuff, and then you give this other payload here, and it passes, it sees you're using the Jinja 2 templating engine or the Twig templating engine. So let's go back. So here, what we're going to do is we're going to replace the payload that we were previously using. So we're just going to adjust the payload here so that instead of 7 times 7, we're going to output 7 times. So if we get this and it comes back, then we can confirm that this is the Jinja 2. Anyways, let's run this. So we get 7 sevens here. This pretty much guarantees that we're dealing with the Jinja 2 engine. And what can we do with this? Okay, so if we supply the above payload and the app doesn't return an error, we can confirm that the app is using the Jinja 2 engine. Okay, so we can just copy this, and this is just going to give us a bunch of output if the templating engine is responding to the code. So we can go back here to the application. We can just put this payload in, and then we can run the payload. So because it actually gives us output, we can confirm that this is the templating engine that's being used, Jinja 2. And so if we're dealing with server-side template injection, there's a very useful website that we can use to get payloads to compromise the application. So I'll just leave it in the app, and let me put it in here. So this is Payload All the Things. It's a very popular GitHub repository, and they've got a bunch of payloads for server-side template injection. So in this case, I got the payload that we're going to be using from this page. And where are we? Okay, so this payload over here, the above Jinja 2 payload can be used to perform OS commands via the SSTi vulnerability, server-side template injection. So if we just copy the payload here, and from now on, we can just paste the payload up into the URL parameter here because it's using the whatever we supply to it as the user parameter here. So we're just going to replace OS command here. We're just going to do who am I? And hello Verde. So Verde is the name of the user that is being, the user that we're acting as in the web application. So we can run any number of different OS commands in this case. So we could cat, etc. password. And this is going to be the user list for the system here. So we see here that the Verde user is the only regular user on the system, aside from the root user. Actually, yeah. So root user is up here. And okay, so what can we do from here? So what we want to do is we want to get direct access to this application. So let's see. Okay, so what we're going to do is on our attacker machine over here, we're going to create a netcat shell. So the netcat shell is going to, sorry, a netcat listener. The netcat listener is going to be on our attacker machine's port 443. And what we want to do is we want to have the web application run the system command to connect to our attacker machine. So this is going to create a reverse shell connection. And this is the payload we're going to use. So let's take a look at the payload. Let's make it nice and big. Okay. So this is a payload that is going to run bash, and then it's going to run bash in interactive mode, and it's going to reach out to our attacker machine's IP address on this port over here, and it's going to redirect everything to standard output to standard output over here. So the payload is this. If we have the web app run this command over here via server-side template injection, it's going to create a reverse shell connection back to our machine. So let's copy that. Let's go to, oh, what was the other payload? Hold on. Okay, so this is the payload here. The problem is, if we run this payload, it doesn't work. It doesn't work. It gives us an internal server error. So can you identify why the payload didn't work and give us an internal server error instead? So it's pretty common that the special characters that you give inside of these reverse shell payloads, they're not going to be interpreted very well by the web application. And what we need to do is we need to URL encode the payload. So we can just go over to any old website for URL encode. Then we're going to URL encode our special characters in our payload. And this is the payload after it's been URL encoded. So if we give this to the application instead of the regular payload, it should be able to run the payload even though it has a bunch of special characters it doesn't like. Okay, where were we? Okay, so we'll just paste in the payload that we URL encoded. And then we'll run it. So when we run this payload, you'll notice that the web page hangs. And because the web page hangs, this means that it's probably not completing the command, which is pretty typical when a web app runs a reverse shell payload. So if we go back to our reverse shell handler or our reverse shell listener, we'll see that we've received a connection. So we ask, who am I? We are the Verdejo user. Awesome. So we'll call in Mr. Scary Hacker Voice Man.
Hey there, everybody. It's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we compromise a server, and we just compromise this one. Well, Mr. Verdejo Administrator, it seems like you're using an insecure app that is vulnerable to server-side template injection. Well, that is a big mistake. We were able to run code on your application through SSTi, and then we were able to get a reverse shell connection. Maybe you knew about the security vulnerabilities on your system, or maybe decided to accept the risk. Well, you accepted the risk. Ha 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 ha. And now we're in.
Thank you very much, Scary Hacker Voice Man. So on most of these CTF boxes over here, what we need to do after we get initial access, which we just did, is we need to find some way to elevate our privileges on the system. Right now we're running as the Verdejo user, but we really want to get elevated access and run as the root user. So the act of elevating our privileges to the highest level of user is called privilege escalation. So if we run this very common privilege escalation enumeration command over here, it's called sudo l. It basically tells you if the current user can run any commands as the elevated user. In most cases, it's the root user. So in this case, it tells us as the root user, without providing a password, we can run the bin base64 command. So base64 is a command we can use to encode and decode things. And let's talk a little bit more about it over here. So for this machine, our privilege escalation vector is sudo base64. So our current user has sudo permissions with the base64 command. And if we use the above payload over here, we can read any file on the system. So in this case, we're using base64 to encode something, a particular file, and then we decode it immediately afterwards. So this is a way we can use to do privileged file read. And if you're wondering where we can get these kind of payloads, there's a website called GTFObins, and this is the website that you can use to figure out if you can use any Unix or Linux binaries to get, well, to abuse privileges and to escalate privileges. And this is the link over here. So what you can do on the GTFObins website is you can search for any binary that you might have elevated privileges with. For example, if you've got sudo or if you have an SUID binary, and you can look up the entry on GTFObins. So in our case, we've got sudo access, and it says if the binary is allowed to run as superuser by sudo, it does not drop elevated privileges and may be used to access the file system, escalate, or maintain privilege access. And in this case, we can use it to read any file on the system. Okay, so in this case, because we have access to sudo with base64, there's an SSH private key present on the system for the root user, which we can access because we have sudo with base64. So what was the payload again? It's going to be sudo base64 and then the file we want to access. So this is something we can do as well, because when we run sudo, we're running as the root user, and we can access any file on the system as long as we know it's there. So in this case, we're going to run it against root, the root directory, the SSH directory inside of it, and the IDRSA file inside of that. So this is a very common location for SSH private keys. And so this is the base64 encoded version of the private key. So if we want to see the regular version of the private key, we would run the same command, but we would base64 decode it with the pipe over here. So when we run it this way, it's still base64 encoded, but this is the original contents. So all of the private keys are going to begin with this line over here, begin open SSH private key, something like that, and they're all going to end with this line over here, end open SSH private key, or something similar. So what we can do is we can just copy all of this, the entire private key, copy it to our clipboard, and then on our attacker machine, we're going to create a file called IDRSA, which is the private key for the root user. So nano IDRSA, paste in the private key, and then we're going to save this out. So when we use the private key, we have to adjust the file permissions, because private keys have to have very specific file permissions before we can use them. So if you see here, the IDRSA private key can be read by global users, and it can be read and wrote to by group users. So we need to change the file permissions in order to use it. So we're just going to run cd chmod to change file permissions. We're going to change them to 600 on IDRSA. That means that global users and group users don't have any permissions, and the file owner can read and write to the file. Okay, so now we're ready to log in as the root user with the IDRSA private key, SSH private key. So the problem is it's going to ask us for a passphrase for the key. So SSH private keys can be configured with a passphrase, kind of like a password, which means we can't use the private key unless we know the password. So this is a little wrinkle in in trying to do our privilege escalation because we need to figure out what the private key is for the IDRSA key in this case. So we can actually extract the passphrase hash for the private key with this command right here. It's called ssh2john. We're going to run it on the IDRSA private key. We're going to output the command to this file right here. It's called key.hash. So this is just going to be the passphrase hash for the private key. So run that. Now, inside of the key.hash file, there's just a password hash, and we can feed this into a password cracking program. So the password cracking program we're going to use is called John the Ripper. And when we run it, we're going to give it the name of the hash file. So it's key.hash, and along with the name of the hash file, we also need to give it a word list. So the word list we often use when we do these easy level CTF challenges, when we're doing cracking, password cracking, is this rocku.txt list. So the rocku.txt list is a list of the 14 million most common passwords, and we're going to compare the password hash here against 14 million of the most common passwords to see if we can get a match. So let's start running that command. So this is trying to crack the password hash. It's comparing against all 14 million of the passwords inside of rocku.txt, and it's going to try to figure out if any of them match. Okay, so are we done brute forcing? Yes, we are done. Okay, great. So we managed to get the passphrase for the key. It's Honda1 in this case. So this means we can log in with SSH using the key for the root user. On the server, it's going to ask us for the passphrase for the key IDRSA. It's Honda1 because we just cracked that password. And now we're the root user. So who am I? We are root, which means we can do this.
What are you? I'm system root.
Okay, so we just rooted the machine, but usually what we would do to prove that we completed these challenges is we would move into the root directory and we would read a file inside of there. Unfortunately, for these Dockerlabs challenges, they don't come with flags, but we can do something a bit more fun with this challenge. So what we can do is we can move into the web directory, and then we can replace the web page on the server with our own web page. So this is what we're going to do. So we've got an index.html file ready to go. And what we're going to do is we're going to leave a little message for the administrators of the web page. So we're going to wget, and we're going to download from our attacker machine. So let's see. The attacker machine IP is this, and we're going to upload index.html to replace this index.html over here. And we need to serve the files by using the Python HTTP server over here. So this is going to make it so that we can download from our attacker machine. Okay, so we download the file, and downloaded and saved as HTML1. That's fine. Let's remove the original index.html, and we'll rename index.html1 to index.html, and then we'll download the HackerFrogs logo. And the last thing we're going to do is we're going to edit the index.html page. Paste in the code. Okay, so we're just going to put in our HackerFrogs defacement page. Okay, hello, Verdejo administrators. We are the HackerFrogs, and we just hacked you. We found a server-side template injection vulnerability on your web app, and then we broke in. From there, we found that your web user had sudo access to Base64, which we used to get access to the root user's SSH private key. Thanks for the access. Sincerely, the Shy Hat. And what month is it today? What day is it today? It is July 16th, 2025. Let's save this out, and then let's go over to the web page to make sure that we've successfully defaced it. Hello, Verdejo admin. We are the HackerFrogs, and we just hacked you. We found a server-side template injection vulnerability on your web app, and then we broke in. From there, we found that your web user had sudo access to Base64, which we used to get access to the root user's SSH private key. Thanks for the access, and better luck next time. Sincerely, the Shy Hat. Dated July 16th, 2025. All right, everybody, that was a guided walkthrough for the Verdejo machine from Dockerlabs. We'll do a little review. The way we got into the machine is we took advantage of the SSTi vulnerability on the web app. Server-side template injection. It's a web app vulnerability where the app uses templating engines to create dynamic web content. But you can inject any user input into the web app if it has an SSTi vulnerability to get remote code execution, and that's how we got into the web app. So from there, we did privilege escalation using the Base64 command that we could run as sudo. And if you can run sudo as the root user, in this case, you can read any file on the system. In this case, we read the root user's SSH private key, and then we logged in as the root user. All right, so if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.